We'll proceed in the volume calculation of the sphere. So we have done all the permutation combination as far as multiple coordinate system, different or various coordinate system is concerned. So we will see the volume calculation of the sphere, something that looks tricky. Volume calculation of the sphere. So that is the place that we consider, probably it should be the last item that we are kind of tackling. Volume calculation of the sphere. What we are doing now? What we are doing? So we are in a phase to calculate consider there is a water tank. This is what kind of we have seen four coordinate system. One is Cartesian coordinate system, one is polar coordinate system, cylindrical coordinate system, and then a spherical coordinate system. Okay. Now the idea is that there is a water tank. There is really a water tank. Means I have everyone would have seen here and there some big water tank. If you have not seen big water tank, then try to find some railway station, especially in India. So some railway station, and you go there nearby. Certainly, you will find a big water tank that is guaranteed. Either it can be British era water tank, means made up of a completely iron or concrete, whatever it is. So big water tank. We are talking about big water tank. So if there is a water tank, then it is hemisphere in the structure. Okay. So if I have a sphere, if I cut it from the middle, then upper portion of the sphere, that is hemisphere. Hemisphere means I have I have a ground, and ground on the ground there is a sphere, half part of the sphere on top and half part of the sphere under the ground. Just discard the under the ground, the above the ground, whatever you see, that is hemisphere. Now hemisphere you take somewhere top, and that is your water tank, new water tank. So that is flat from the bottom, flat from the bottom, and on top it is like this. This is hemisphere with radius a, that is small a. Now question arises is that if water is getting filled from a pipe and it is going to level h, then what is the volume of the water? If that h is 0, then there is no water. If h is a, then it is full of water. So full of water means the volume of a sphere is 4 by 3 pi a cube. So half of the sphere, hemisphere, if water tank is full, then 2 by 3 pi a cube is the water amount that is there. Now question arises is, if it is height h, then how much water is there? Through cylindrical coordinate system we calculated. So what we calculated through cylindrical coordinate system, as far as water is concerned, then we went with the functionality called dv and triple integration. Two way of integration we have talked about. One is we take infinitesimal small volume, and then we generalize it for full volume, dv triple integration. So if we see dv, then it is r d theta dr dz. R d theta dr is the plane. This is typical cylinder. Okay, so this is base, that is circular, and then height. This is even better cylinder which has a base, or which has a base that is circular, and then there is a height. So cylinder has a circular base and one height. So circular base area is pi r square, and then height is h, then volume is pi r square h. If we talk in small area in the base, then it is r d theta dr, and then height is dz. R d theta dr dz is a small volume inside this. If I take any cylindrical small volume, then that is r d theta dr dz, where z is height from the base, r is from center, that is the distance of the dv, and theta how much it is rotated. So that is like that. Now we went for integration. So r d theta dr dz, r dr d theta dz. R dr integration is r square by 2, where r, if it is a sphere, we are talking about sphere. We are talking about a sphere. We are sphere, okay, sphere, half of the sphere. So sphere, the radius at the base, that is the hemisphere base, is a. If we go along, is a. If we go along, then radius will start decreasing and slowly it will become 0. Okay, so that is the concept of any circular, any hemisphere. I have big sphere now. Okay, so concept is, if I have a sphere, then at the center, if I cut the sphere, then upper portion is hemisphere. So if I cut it and lower portion I discard it, then at the base, the radius is full radius of the sphere. But as we go along up, 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 then if we see the cross-sectional radius, it is smaller. If we go at the top, then radius is 0. There is no radius. So radius is has dependency upon the height. That is fair if we see the cylindrical coordinate system. This is what we saw. So radius from 0 to, if I make a cross section at any place at height h from the center, height h from the center, if I make a cross section, the radius is r, this is height, then hypotenuse is a, that is the radius of the sphere. So the radius is, the height is a square minus r square, that is the height, or radius is a square minus h square. Okay, so consider this height as z, so a square minus z square is the radius square at any cross section. So radius leave it 0 to a square root of a square minus z square. So we have integration r square by 2, that turns up into a. If I place limit 0 to square root of a square minus z square, that will turn up into square a square minus z square by 2. Now then d theta integration full. If theta is in the, if I cut it along the equatorial, in whatever plane comes, then theta angle 2 pi, 0 to 2 pi, 2 pi, 2 to cut down pi comes, pi I can keep outside. Now a square minus z square dz. dz is from base to height is 0 to a. Okay. So whatever is the most independent, we keep outside. So z is the most independent, theta is most independent, we keep outside. Now if we see the integration of a square minus z square, then a square z minus z to the power 3 by 3. Pi is outside. Now, if we replace z with h, then a square h minus h to the power 3 by 3. This is the volume of the water at height h. Okay, so I'm sorry, z I had taken 0 to a in the integration, 0 to h, because we want how much it is filled, 0 to h. So theta r is 0 to a square root of a square minus z square. Theta is 0 to 2 pi and dz is 0 to h. Now a square minus z square integration is a square z minus z to the power 3 by 3. Now if I, now I have to substitute 0 to h. So a square h minus h to the power 3 by 3 whole into pi. That much water is there when the hemisphere water tank is filled till height h. Now let's replace h with a square h minus h to the power 3 by 3. So h with a, so a to the power 3 minus a to the power 3 by 3, that will come as 2 a to the power 3 by 3. 2 pi a to the power 3 by 3. That is nothing but volume of hemisphere. So that much water is there. I had given assignment also that if it is a hemisphere and then if it is a hemisphere and if I take height h only and cut the hemisphere top. So if I have a hemisphere goes till full. I make a cross section at height h and top portion I throw it away. If it is equatorial, then bottom portion anyway I have thrown it. That's why it is hemisphere. So the if I have a water tank like this, hemisphere with height h and top of that is thrown away, and then if I make it of steel iron, that water tank and cover I fill it with again a steel, then what is the surface area bottom again with the steel? So I can just keep it somewhere. What is the surface area of the full steel that someone has to will calculate that. So if I have a water tank where hemisphere where bottom portion is a concrete steel and then it is a hemisphere like this, then up to height h it is cut down, top I throw it away, it is not there, then top I cover it with a steel, then how much is the steel required to make it? If I know what is the surface area of the steel, if I know the density of the steel per kg square, kg per meter square, then how many kilogram of the steel I need to purchase? Anyway, now we have found that if it is height h, then water volume of a hemisphere water tank is pi and in braces a square h minus h to the power 3 by 3. Now, can we calculate this in cylindrical coordinate system through other way in integration? That is the question. Other way in integration means I have a function f r theta. Generally, we say f x y, f r theta. So that is a function. If I have a hemisphere, I mean if I have a cylinder, the cylinder has circular base, and then there is a height. If that is true, then this height is height is a dependent component where independent component is the circular base, that is xy plane or r theta plane. So if it is r theta plane, then if I have a function over the independent component that is r theta plane, that function would give me the height f braces r theta plane or f r theta. So if I integrate f r theta with d r theta plane, it will give me the complete volume. We have talked about it. So in integration, if I have a r theta plane and there is a f r theta surface, if I calculate integration, it gives me the volume. Please refer past video. If that is true, then f r theta d r theta plane, f r theta function over r theta, d r theta plane gives me the volume, single volume from in r theta plane one point to other point. So now f r theta is how much? Now if there is a hemisphere and there is a base and there is a height, if I make a cross section, then again it is a circle with same configuration what we see at the bottom. But we have filled we have filled our cylinder with a sphere. Sphere is inside now. Okay, a sphere is going inside. So since I have filled this cylinder with cylinder with a hemisphere, then if I make a cross section any point and see the radius of cross section, height is h that we have talked, radius is r, then diagonal is a, that is the radius of sphere. R is variable and it is 0 at the top, and at the base of hemisphere it is a. So the height h is nothing but a square minus r square. That is the formula now. F r theta a square root of a square minus r square. D of the r theta plane, that is r dr, r dr d theta, and then integration. So r dr d theta, and a square root of a square minus r square. So I have to integrate now r, a square root of a square minus r square dr d theta, where r is r. Now this is a concept here, that what is r here, and we have only two variations, r and d theta. So r, where from where it would go. Okay, so r, if I if I am taking this, then let's consider that earlier the r, we had r here. Okay, r, let's proceed. So r, square root of a square minus r square. The integration of r, square root of a square minus r square, is a square minus r square to the power 3 by 2 whole by 3. If that is the case, then minus 1 by 3 into a square minus r square to the power 3 by 2. If this is the integration, then differentiation of this is a square minus r square to the power 3 by 2. Differentiation is 3 by 2, a square minus r square into 1 by 2, then minus 2r. 2 and 2 cut down, 3 and 3 cut down, minus minus cut down, then r, square root of a square minus r square. So perfect. Minus 1 by 3, then a square minus r square to the power 3 by 2. That is the integration. Now if I take the radius from radius r, okay, radius, if I take 0 to a, then I'm sorry, so it is a square minus r square, a square minus r square. That is the concept. A square minus r square, and in braces power 3 by 2 minus 1 by 3 a square minus r square. Okay, so that is the funda, and then 3 by 2 d, this is the integration, and again d theta is the integration. Now what is the radius limit that we want? What is the radius limit that we want? Now, if I take radius of the sphere, okay, so from 0 to a, then it will give me something like full hemisphere. If I take 0 to a, we can try 1 by 3 a square minus r square to the power 3 by 2. If I take 0 to a is full 0. If I take 0, then a to the power 3. A to the power 3 by 3 minus gone. So a to the power 3 by 3. Then d theta 2 pi. So 2 pi, then 2 pi a to the power 3 by 3. This is exact the volume of a hemisphere. Then what are we should take? Okay, so r is the, if I have a hemisphere, then hemisphere, half portion of it. If I have a hemisphere, then base radius is a, that is the radius of a sphere. If I keep moving up, then we have r equal to a, the temporary r equal to a. If I keep moving up, then r is becoming smaller, smaller, smaller. Okay, up till r, we have to take r where the height is h, that r only. So r from a to kind of r where there is a height h, that much only we have to take. We will try r from a, up till r, up to height h, that much r only I have to take. If I do like this, what we are trying to do? If I have a hemisphere, in the hemisphere, if I take from a to r, that is up till here where h is there, okay, then we calculate the slant volume, not the this volume. Please concentrate. So if I We are doing really churning. Okay. So if I have a hemisphere, and then hemisphere, the height is radius a of the sphere. Then this side a and this side a. Okay. Now, if I at any point there is a circle. Everywhere cross section is a circle. At any moment, the radius is r. Then height is h. Okay, and then hypotenuse is a. Now, if I take limit from here, any r if I take at height h r, from that r till the end, then this volume we are calculating, not the cylinder what is coming in between. There is a cylinder in between. If water tank is a hemisphere, I fill the water till height h, then water is there and it touches the surface of the tank. Then again water is there in the slant area of the tank. Where it is touching both sides, there is a full-fledged cylinder. And then right side and this side, then we have the spherical region. If I take radius from this location to end, this volume we are calculating leaving the cylinder. So what is this volume? That is, what is the R? So R at any moment is A square minus H square square root. From there to A, if I take the R, then this portion leaving the middle cylinder, it is understandable. If I have a hemisphere base is there and then hemisphere, where height is A and from the origin, right side is A and this is the radius of the sphere. Now, if I go h height and see the water, then water is there, and then water will touch the hemisphere surface. From there again water will take round shape. Here left side also water will touch the place it will touch. From there it is a cylinder, and then there is a spherical curve. If I take radius from this point where it is touching the sphere till the end, then this portion volume we are calculating. Okay, and then this volume we are calculating. Cylindrical volume we will calculate separately and we will add, then we will get the volume of the water. So if I place limit, okay, so limit is now square root of a square minus h square till a, and there we have a function that is square root of a square minus r square root of a r square minus r square r d theta, dz gone. Now, if I did the integration, it came as minus 1 by 3 a in braces a square minus r square to the power 3 by 2. If I keep the limit square root of a square minus h square to a, if I put a there, it is 0. Now I put this square root of a square minus h square. So a square minus in braces a square minus h square full power 3 by 2. A gone, and now it came as h to the power 3. It came as h to the power 3. So net integration is now h to the power 3 by 3. H to the power 3 by 3. If this is the case, then now we will integrate theta, d theta 0 to 2 pi. So 2 pi h to the power 3 by 3 is the volume of the slant region. Middle cylindrical region is remain. So we have now formula as 2 pi by 3 h to the power 3, that is the slant region volume. What is the middle cylindrical region volume? That is pi r square into the height. Pi r square into the height. So pi r square, pi r is nothing but a square minus h square into h. So pi is outside a square h minus h to the power 3. Okay. So a square h minus h to the power 3. Okay. Plus 2 pi h to the power 3 by 3. So this is the volume. So pi in braces a square h minus h to the power 3 plus the what we got earlier plus a to the 2 pi by 3 h to the power 3. Now, if we take care of these two calculations, okay, then I mean whatever come is the volume. It would be same we are to we what we had calculated earlier pi and then a h minus h to the power 3. Okay, so that is the concept. Someone can try it. So pi a square h minus h to the power 3. Okay, and then we have pi 2 pi 2 pi h to the power 3 by 3. So here minus is pi h to the power 3 minus pi h to the power 3 plus 2 pi h to the power 2 pi h to the power 3 by 3, that will come as pi h to the power 3 by 3. So pi a square h pi a square h minus, okay, pi a square h minus pi h to the power 3 by 3. So pi outside, then a square h minus h to the power 3 by 3, same thing. Okay, so we calculated the volume of a water tank, that is a hemisphere, where volume of water inside the water tank, where the volume of the where water tank is a hemisphere with radius a and water is filled till height h through two ways. One is through dv and another is through the traditional integration. We have the fr theta, and with fr theta d of the r theta plane, through that we calculated. So both places it came as pi and outside and braces a square h minus h to the power 3 by 3. Okay, so let's try computing through a spherical coordinate system. So probably I'm really sweating. So probably we can try later. So in the spherical coordinate system, two ways we can go. Again, dv integration with dv, and then again integration with the functional. So if we see in integration with the function, then function is nothing but df. Again in a spherical coordinate system, if I cut the sphere from at the equatorial plane, then there is a hemisphere. If it is a hemisphere, then bottom part is a circular region. The bottom part is a circular region, that is a function of r theta again. So f r theta dr theta plane, and then single integration from one point to two point in the r theta plane gives me the volume. So what is the height? If I see the fr theta is nothing but the height. So fr theta, if you make cross section, then height is nothing but a square root of a square minus r square, and d of r theta plane is r d theta dr. Okay, now integration from one limit to other limit. So the radius is again square root of a square minus h square to a, and then 0 to 2 pi. So this again gives me slant region volume and then middle region volume, that we have to calculate same thing. So we came to same stage what we had in the cylindrical coordinate system as far as traditional integration is concerned. Okay, so as far as traditional integration is concerned, then we came to same formula, that square root of a square minus r square r dr d theta, where r is from square root of a square minus h square to a, and theta is 0 to 2 pi. If I calculate this, then I get 2 if it is a hemisphere and water is at some level, it is touching the hemisphere. So from there, whatever curve we see in hemisphere, that water content we get. And in between, we have the cylinder. So this then we will add with the pi r square h. So pi r is a square minus h square into h. If I add all this, so pi a square h minus a square minus h square bracket close h plus integration 0 to 2 pi integration square root of a square minus r square to a, and then square root of a square minus r square r dr d theta. If I calculate all, then we get the content of the work. Okay, so the most crucial thing in the coordinate system as far as the spherical coordinate system is concerned, that calculation with the dv. Calculation with the dv. So what is kind of dv? So dv in a spherical coordinate system is a one spherical small v. In cylindrical coordinate system, if we see dv, then it is simple small cylindrical region. If I have a cylinder and inside cylinder at height z from center at radius r and angle theta, I take a small volume. That volume is small cylindrical volume. In Cartesian coordinate, if I take a small volume, that volume is cubical volume. That is x, y, and z distance. That is then width, height, and length of the volume is dx, dy, dz. Here in cylindrical coordinate system, one section is dr, another section is r d theta, and another section is dz. What about if I take a spherical coordinate system? Inside that, if I have a small sphere, okay, then it is r distance, it is at it is r distance from the center. Sphere, if I take a spherical coordinate system, if I take a spherical coordinate system, if it is centered at the origin, then a is the radius, then a radius goes all along. If it is equatorial plane, then radius is again a. If I go this direction, then radius is again a, touching the sphere. Everywhere it is a radius. Where cylinder, that is not the case. Only the cross sectional radius is a. If I go from center anywhere, it will be different. Okay, so Cartesian coordinate xyz will be different if I take anywhere, but here from the origin, if I take the radius a, it is everywhere radius a only. Now if I take radius r from center, if this is centered at the origin, if it is centered at the origin, then from the origin to the surface, if I take a radius r, that is in n root to a, from the center en route to a, if there is a radius r, at r I have a small spherical volume. That volume is located, if I take equatorial plane or r theta plane, then it is at angle theta. This is theta, angle theta. And then if I take vertical plane, then from vertical it is at phi. Now you understand where the dv is located. So dv is located from phi angle from the vertical, and in the horizontal plane it is theta, and then at radius, if it is theta and it is phi, then horizontal and vertical, that we are fixing, and then at radius r, there we have a small volume, that is dv. What is the dv? dv, if it is a volume, then it has three sides. One side is the horizontal arc, another side is the vertical arc, horizontal arc, vertical arc, two sides, and then third side is the radius. Well, this is how it is. Don't claim that it doesn't look like a real volume that we see in Cartesian coordinate, where it looks like a cube. Okay, a spherical volume is like this only. So spherical volume, if you see, then it is mixture of three coordinate. One coordinate is if there is a kind of a theta. Okay, if I talk about r is a radius somewhere, and this is phi angle, then r sine phi falls on the xy plane. If r sine phi falls on the xy plane, then r sine phi, r phi from the vertical. This is the angle. This is r. This is r. R sine phi falls on xy plane. R sine phi d theta. This is the arc. So if I have a small volume, it has three directions. One direction is r sine phi d theta. This is one arc. Another arc is r d phi. If it is arc and this is phi, then r d phi. So one arc in the xy plane or r theta plane is r sine phi d theta. In another plane, so another plane we have r phi, r d phi, r d phi. Two plane, one plane and this plane. What about third plane, that is the radius? Third chord orthogonal coordinate, it looks little awkward, but this is how it is. So if this is, there is r radius, then if I go little bit along, then it is dr. So the infinitesimal small volume in the spherical coordinate system is nothing but r sine phi d theta r d phi dr. So r comes twice. So r square sine phi d theta dr. That is the volume. If we see the uh, cylindrical coordinate system, then if it is a cylindrical coordinate system has a circular region and then perpendicular. If I take any volume, then volume will be cross section everywhere. It is same radius a. So from, if I take vertical axis and if I take a cross section and there somewhere the dv exists, then it is at radius r, and then it is little bit rotated in r theta plane, then it is angle theta, and then it is at height z, then it is z. Now if I talk about the volume, then horizontal base into height is the volume. So horizontal base area is r d theta dr, because there is no concept of this in cylinder. Everywhere flat region is there. That's the same. And then height. So it is something like mixture of polar coordinate and Cartesian coordinate. Hybrid model is cylindrical coordinate system. So dv there is r d theta dr, that is the base area into height dz. So dv in the cylindrical coordinate system is r d theta dr dz. Now, but in the spherical coordinate system, there is no concept of the kind of base and height, because height region, it is a slant region in the spherical coordinate system. So everything is angular. So if I take any volume dv from radius r, from center, if I take r, this is the sphere, and this is xy plane. From center, this is the origin. From there, if I take r, if I go along with the r, it will hit the curvature of the sphere, that is a. So any distance r. Okay, now r. Now this r, if I move along theta degree in xy plane, it will go little that side. And then that r, if I move little bit, that is from phi angle from the vertical. From vertical, that r is at phi angle, and then theta angle in this direction. So there the d volume is there. So what is the formula of d volume is? Now it has three sides. One is the curve in the d theta r d theta plane. One is in the vertical plane, and one is the dr. So one is r sine phi d theta, one is r d phi, and one is dr. So the d volume is r sine phi d theta r d phi dr. Now this volume I have to do triple integration to get the volume of the whatever we want. So we will proceed on it. I'm really sweating. So then we will go with the surface area again. In the water tank we talked about a hemisphere, and then what is the surface area that we can kind of think about at height level h. What is the surface area if it is a full enclosed tank, water tank? Then how much steel I need to make this? Okay, what is the surface area? If I know the density kg per meter square, then how much weight I need to pay for it, or I need to purchase. So this we will see. Okay, so coordinate system is not that easy, but if you are master in coordinate system, master in vector, and then master in algebra, master in calculus, you will crack machine learning, artificial intelligence, deep learning. I can bet on this. Deep learning in those places are nothing but it's a full-fledged vector algebraic calculus. There is nothing more than this. You have to find the components as features and, and then vectors and then start differentiating and integrating. Okay, that way you have to stabilize the model is nothing but mathematical formulae on which is ready for any new data to come in, and then it passes through that mathematical formulae and immediately it says that it belongs to which cluster or which class. So making that formula in machine learning, that requires heavy calculus, vector and algebra. Probably someone in master in coordinate system, that will help even more. Please see our kind of a new disclosure. You can type in at the Google. So go to Google search and type in unsupervised learning. Unsupervised learning clustering K means algorithm. Unsupervised learning clustering K means algorithm. It has come in code project, codeproject.com. Just pass code project, CODEPROJECT, code project. We'll take it at our website also, meaning.42web.io. Everything is available. You can see other places also. So meaning.42web.io. There we will place the new disclosure link, or in Google just type unsupervised learning clustering K means algorithm code project, CODEPROJECT, code project. Then you will come to a new disclosure 1 day before it came, and there you will see the how much calculus we are using to get to some conclusion one thing, and then we are the first one to do the computation through cosine distance that comes in spherical coordinate system. So a spherical coordinate system and Cartesian coordinate system, both we are using Euclidean distance in Cartesian coordinate system, and a spherical coordinate system that we are using angular 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 distances, then calculus, partial derivative, everything is there. So please read it, enjoy it, learn it, whatever is more suitable to you.